Hello, welcome to ANS Solver. This is the 10th question of the paper, and as you can see, this is a differentiation question. So the diagram shows us an equation here. Okay, we need to find the x coordinate of m. We know m is a maximum point. A maximum point basically means it's a stationary point. Okay, so now when we want to calculate the x coordinate of m, we first calculate the gradient, which is the dy by dx. For this, we use something called as the product rule. Okay, as you can see, e raised to cos x is multiplied by sine cube x. So I take my u as e raised to cos x. I take my v as sine cube x. I take my u dash basically as, first I differentiate e, which is the same as e raised to cos x, multiplied by the differentiation of cos x, which is minus sine x. So I can write this as minus e raised to cos x sine x. In the same way, I have v dash, which is the differentiation of sine cube x, which can be written as 3 sine square x first, differentiating the 3, into the differentiation of sine, which is cos. Okay, basic chain rule, correct, basic concept. Okay, now the formula of my product rule is uv dash minus vu dash. So I can basically write this as uv dash, I know is e raised to cos x multiplied by 3 sine square x cos x minus vu dash, which I can basically write as, sorry, there's a plus here, my bad. Okay, minus e raised to cos x sine x, okay, into sine cube x. So now I can basically write this as 3 e raised to cos x sine square x cos x minus e raised to cos x sine raised to 4x. And I know this is equal to 0. Why? Because I know m is a maximum point, which gives me that it's a stationary point, and in a stationary point the dy by dx is always 0. Okay, so I can equate this to 0. So now I can simply take e raised to cos x and sine square x common, which I basically get 3 cos x minus sine square x, which I know is equal to 0. So I can write this as e raised to cos x sine square x being equal to 0 and 3 cos x minus sine square x equal to 0. Okay, I know this cannot be solved. Okay, so now what I can do is I need to only focus on this. So now I can basically write this as 3 cos x, okay, minus, you need to know one important trig property here that suggests that sine square x plus cos square x is equal to 1. Hence I can say that sine square x is equal to 1 minus cos square x. So in the same way, in the place of sine square x here, I can substitute 1 minus cos square x, which is equal to 0. So I can write this as 3 cos x minus 1 plus cos square x, which is equal to 0. Got it? So now I can write this as cos square x plus 3 cos x minus 1 equals to 0. Now I can say let cos x be a. So I can basically write this as a square plus 3a minus 1 equals to 0. So now what I can do is, I know this is a quadratic, which I can simply solve on my calc. So on my calc, I can go, this is on the calc, okay, just in case, I can go on mode. After clicking on mode, I can click on 5 where equation is written. When I click on 5, I can click on 3. When I click on 3, I get 3 coefficient boxes. Okay, these are called coefficient boxes on your display. In the first coefficient box, I can put 1, which is the coefficient of a square. In the second box, I can put 3, which is the coefficient of a. And in the last one, I can put the constant, which is -1. Okay, so 1, 3, and -1. And when I click on equal to, I basically get my a as 0.3027. Okay, and I get my 3a as -3.3027. Now simply I know cos x is a, so I can write cos x equals to 0.3027. Okay, and I can say cos x is equal to -3.3027. Now I can straight away eliminate this because I know cos x lies in between -1 and 1. Correct? That's the range. But this is -3.3027, which does not lie in the range. Now what I can do is, I know my domain here is basically 0 to pi. So I can be on the radian mode and simply just do cos inverse, okay, of 0.3027. And when I do that, I get my answer basically as 1.26 to 2 decimal places and 3 significant figures, which is basically the final answer of the question. Okay? Now, yes, so this is the second part of the question. So what we basically need to do here is, we need to first, substitute u as cos x and find the area of r. If you notice, r here is basically, the area in the circle, the shaded area in the circle, which has, I know, the limits of 0 and pi. Okay, so I basically integrate from 0 to pi, okay, the equation e raised to cos x into sine cube x dx. Okay, now what we basically need to do is, we need to take our u as cos x. If I take my u as cos x, I take my du by dx basically as a differentiation of cos x, which is simple, which is minus sine x. So now I can basically write this as du by sine x equals to dx. So now what I can do is, I can write this basically as, without the limits because I'm writing in the terms of u, so e raised to u, okay, into sine cube x. Sine cube x can be written the same as it is sine cube x, and instead of dx I can simply write into du by minus sine x. Now what I can do is, I can cut the sine x here and I can cut this and make this sine square x. So I basically get minus e raised to u into sine square x, into sine square x du. But now we need everything in the terms of u. So I need to convert sine square x in terms of u. So as we did in part A, you need to know the trig identity, that sine square x plus cos square x is equal to 1, which gives my sine square x as 1 minus cos square x, and I know my cos x is u. So cos square x can be written as u square. Okay, so I can write this basically as minus e raised to u into 1 minus u square du, which can basically be written as e raised to u into u square minus 1. Basically, I took the minus inside du. Got it? Now, to solve this, we need to use something called as integration by parts, which basically has something called as isolate. Okay, where I is the inverse, L is the logs, L is logs, A is algebra, T is trigo, and E basically means exponents. If you see here, e raised to u belongs to exponents, okay, and u square minus 1 belongs to algebra. Now in the order of isolate, algebra comes first. So I get my u as basically u square minus 1, and I take my v dash as e raised to u. Correct? So I can take my u dash as the differentiation of u square minus 1, which is simply 2u. Correct? And my v here is the integration of e raised to u, which is e raised to u. Now my formula which I use is uv minus the integration of vu dash. So u into v is simply e raised to u into u square minus 1, okay, minus vu dash. Vu dash can simply be written as 2 e raised to u into u, okay. So now I can write basically this as e raised to u into u square minus 1 minus I can integrate this again using by parts. So this is basically a very good question because this substitution which has by parts in it, which again has by parts. So here if you see e raised to u is exponents and u is algebra. So I take my u basically as u, and I take my v dash as e raised to u, 2 e raised to u. So I can write this my u dash as 1, and I can write my v as 2 e raised to u. So u into v gives me 2 into u into e raised to u minus the integration of vu dash, which is 2 e raised to u. So I can simply write this as 2u e raised to u minus, I know the integration of 2 e raised to u is the same, okay. So now what I can simply do is I can write this as e raised to u with u square minus 1 minus 2u e raised to u minus 2 e raised to u. So this can basically be written as e raised to u into u square minus 1 minus 2u e raised to u plus 2 e raised to u. Now I know my u is cos x, so I can write this as e raised to cos x with cos x square x minus 1 minus 2 into cos x e raised to cos x plus 2 e raised to cos x. Agreed? Now when I have cos x, I can write my limits again, which is 0 and pi. Now I need to give the exact value. So first I put pi in the equation. So now if you see, you have cos everywhere. So what you can do is on the radian mode on a calci, just do cos of pi. When you do cos of pi, you know your answer is minus 1. So wherever you see cos x, just substitute minus 1. So I basically get e raised to minus 1 with minus 1 the whole square minus 1 minus 2 into minus 1 e raised to minus 1 plus 2 e raised to minus 1. Agreed? Minus, now put 0, which is basically the lower limit. So do cos 0 for that, and wherever you see cos, just put positive 1. So e raised to 1 with 1 square minus 1 minus 2 e raised to 1 plus 2 e raised to 1. Correct? So now I can basically write this as, I know e raised to minus 1 can be written as 1 over e, and your 1 minus 1 will give me 0. So I know this full thing is, this full thing here is technically 0. Okay? Now I know here I simply have 2 over e raised to 1 plus 2 over e, correct? This is what I have, okay? Minus, I have again 0 here and I have 0 here. So this full thing is 0. So I basically get 2 over e plus 2 over e, which I can simply write as 4 over e, which is basically the final answer of my question.